Hi everyone, Dr. Leininger back here, and this quick video is going to review some concepts that we have already discussed in the video lectures. But as I was thinking about some of these things the other day, I realized that I discussed a lot of them but did not necessarily have them written down. And most of the time what I do is I write additional content on the board or draw pictures or things like that. And I didn't really have the opportunity to do that for you with the lecture slides that I was working off of. So I thought I'd do this quick little video to talk about some of these concepts and jot down a few more things for you so that it should help get this content manageable for you. So you'll see here, KIN 390 Unit 2 review. This is not an exhaustive review in terms of like a study guide or anything like that. So you can find your study guide or your activity that you normally do for Dr. Beckham on iLearn. This, like I said, is just a few items that I think are worth reviewing because there wasn't, for many of these things, not a dedicated slide with text on them. So without further ado, I don't know, what would that concept be? Ado? Okay. Without further ado, let's review some of these things. I'll remind you that with that gaffe, I'll remind you that I don't edit these videos or anything unless something major happens. I'm working from home. The dogs are pretty quiet right now. If they start to get too noisy, I'll pause it and I'll come back, but I'll let you know when that has to happen. Okay, so the first part here, terms. All of these terms appear in the slides, and this is not an exhaustive list of terms from the slides, so you can review these on your own. But I did want to go ahead and just jot down for gluconeogenesis that this is a process, and I'm going to type while I do this too. So this is a process where you can synthesize a glucose molecule from a non-carbohydrate source. And you can do this in several places in the body, but the examples that we're going to or have talked about are actually in the liver and the heart. So we will get there. But gluconeogenesis, like I said, is a process where you can synthesize a glucose molecule from a non-carbohydrate source. For example, lactate. So that's the one I want to make sure that you understand here for the terms. The other ones, all in the slides and your textbook, and you can fill those out on your own. So for the concepts, one of the concepts we talked about was a graded exercise test. A graded exercise test is actually named pretty well, and it's pretty clear that what's going on here is that it is an exercise test where each stage gets progressively more intense. So for example, what would happen here, like each stage could be 2 minutes, which is pretty normal. And then every 2 minutes you increase, this is just an example, so each stage is 2 minutes, and then every 2 minutes you increase that intensity by 1 mile per hour. So that's a graded exercise test. Graded exercise tests are done a lot in fitness testing and like tactical athlete annual fitness testing. And you don't have to go to max, but a graded exercise test would have to be done if you're going to do a VO2 max test. We watched a video on that, so that's the next concept here. So the VO2 max procedure and protocol. For you, if you're running a VO2 max, what you want to do is ask your subject or your client to run or cycle, whatever they're doing it on, these are the two most common, for as long as they can. As I mentioned, that's in our lecture slides, that's not very technical, so you're going to see down here, if someone reaches true VO2 max, the test criteria is that there will be a plateau in VO2 despite increasing intensity. there will be a plateau in heart rate despite increasing intensity, and an RER, or respiratory exchange ratio, of over 1.15, which indicates CO2, non-metabolic CO2 production, which means that you've gone essentially anaerobic, because remember what happens is that as you produce a lot of lactate and you try to buffer that in the blood to get it back down to normal levels, CO2 is a byproduct of that reaction. So if you get a lot of non-metabolic CO2, then what's going to happen is your CO2 is going to spike, and if your RER is the equation VO2 over VCO2, when you have a ratio like that, if the bottom number is bigger, then it's going to skyrocket, essentially. The ratio has the potential to be over 1. And so an RER of over 1.15, remember, indicates that you have a lot of CO2, which means they've gone anaerobic, or primarily anaerobic. So you're going to ask your subject or your client to run or cycle for as long as they can, and hopefully they meet these criteria, because then you know that they truly reached VO2 max. So what are the protocols that you can use for VO2 max? Essentially, any kind of graded exercise test will do it, where each stage gets progressively more intense. However, in your ACSM guidelines, you will find several, including things like the Bruce protocol, which is very popular, the Balke protocol, which is very popular, and others. So you can check those out. Now, when you have someone on a treadmill or a bike and you have them hooked up to the metabolic cart, then you're doing a direct VO2 max test if they go to volitional exhaustion. However, it doesn't always, and it isn't often, the case where we have that ability. So with VO2 max being the best indicator of aerobic fitness, what we often do are field tests. And field tests are going to estimate VO2 max based on some kind of test, obviously a field test, right? So it's going to estimate VO2 max based on equations with information obtained from the protocol of the test or the procedure. So in your, again, ACSM guidelines, you can find these tests, these field tests. And for example, you can do the 12-minute Cooper run. You can do the Rockport walking test. You can do a swim test. You can do a 1-mile swim, a 1-mile run. There's the YMCA bike test. So there's a bunch of tests that you can do, and you'll notice, obviously, that these are all aerobic activities, because, of course, aerobic activities are what we're going to look at when we are evaluating oxidative capacity or aerobic capacity. So there's a whole bunch of field tests that you can do that are going to estimate it. So if you do a true VO2 max on the treadmill, that's direct. Field tests estimate VO2 max. And there's equations. So for like the Rockport walking test, you'll plug in things like your age, your finish time, your heart rate, and you'll use a different equation if you are male or female. So that's the test criteria as I discussed when you're doing a direct test for direct testing. Otherwise, you're using the protocols from the ACSM guidelines. Okay, and then last concept that didn't have a slide, but I think it's important that we talk about, are those fates of lactate. So when you produce more lactate than you can clear, or I should say when you produce any lactate, where does it go? And at rest, remember, at rest we actually have about 1 millimole per deciliter of lactate in the blood, and that doesn't cause any issues. You don't feel it, it doesn't cripple metabolism, it doesn't inhibit muscle contraction, so you have to just get it back down to those, or you have to just manage those levels, and you do. But when you start exercising more and more, and you get more and more and more lactate produced, you're going to have to work harder to clear it. So where does it go? So lactate can actually go to the heart and be used as a fuel. It can also go to the liver and be used as fuel. And what's going to happen in the liver is something we call the Cori cycle, and it's a gluconeogenic process. Where you take lactate and then you build glucose out of it. So it goes from lactate to glucose. It can also go to adjacent muscle cells. You may have heard of the lactate shuttle. I believe Dr. Beckham has a link to a George Brooks interview, and George Brooks is like the king of lactate. So it can go to other places through the lactate shuttle. It can be bicarbonate buffered in the blood, and I discussed that in terms of it's going to end up producing more CO2 for you, but it will essentially neutralize it. But if all of these systems, if all of these removal processes become overwhelmed when you make too much, what happens is that it's going to accumulate, right? So at rest, you may have 1 millimole per deciliter of lactate, and I've seen values go all the way up to, 15 millimoles per deciliter. So you can accumulate quite a bit in the blood. And eventually, that's going to have to make you slow down or stop, right? Because it does cripple metabolism and inhibits muscle contraction. I just thought of one more concept, and so I'll go ahead and put that here. And I'll talk about this oxygen consumption. So oxygen consumption, something that I don't think was on the slides, was things like rest. So at rest, the typical amount of oxygen consumption is 3.5 milliliters per kg per minute. Remember, that's the relative term. The relative term is you take body mass into consideration. So at rest, 3.5 mils per kg per minute is pretty typical. It's not exact, but it's typical. And then remember, every time you use 1 liter of oxygen, O2, you have consumed about 5 kcals. And that we did have on a slide because it was the RER slide that had the different amounts of oxygen and the substrate use when you are doing different intensities of exercise. But that's a nice little estimate where you can, if you do your certification exams and they ask you about these kinds of things, that 5 is a really easy number to remember. So once you consume 1 liter of oxygen, you've expended 5 kcals. Okay? And then I discussed the fact that ACSM guidelines will have the categories for aerobic fitness, and based on your VO2 max or estimated VO2 max, it will give you, excellent, good, etc. For those values. Okay, so again, this was just a quick video to make sure that you got down the additional information. I'm sure this isn't everything, but definitely some important things that I typically write up on the board. So I hope this is helpful. If you have any questions, comments, concerns, to email me and I will get back to you as soon as possible. All right, take care and happy studying.